Welcome back to 3 Inquisitive Kids. On this video, we'll be learning all about statistical dispersion. Chapter 6. Understand range, variance, and standard deviation in statistics. This is the last lesson of our 8th grade math course, Unit 6. So, again, if you've liked the past lessons, be sure to subscribe and you'll be notified when new content is uploaded. Learning goals. Understand the meaning of range and master the calculation method of the range. Understand the meaning of variance and standard deviation and use sample variances and standard deviations to estimate population variance and standard deviation. We're first going to talk about range. In order to improve the international competitiveness of agricultural and sideline products, some industry associations have divided the specifications of agricultural and sideline products. A foreign trade company wants to export a batch of chicken legs with a specification of 75 grams. There are currently two factories providing sources of goods. Their prices are the same and the quality of the chicken legs are similar. So we pick out 20 random chicken legs from factory A and B, and these are their qualities. So these are the 20 qualities of factory A, and these are the 20 random qualities of factory B. Can you estimate the average quality of chicken legs drawn from factory A and factory B from the graphs? Draw a straight line on the graph representing the average quality. So we're going to answer these two questions together. As you can see, this is the chart that shows the quality of chicken legs from factory A, and this is from factory B. And the first one is the average qualities of chicken legs extracted from at factory A and factory B is about 75 grams. So all you're being asked to is to estimate. Here how I know this is 75 grams is that this is about like halfway through. So this could be the median, and that would be 75 grams. This is also 75 grams. So like about 76, 75. So their average qualities is about 75 grams. And can you draw a straight line on the graph representing the average quality? Well, you have a scattering of dots on this plot, but if you were to represent all of them with a straight line, then you want to make that line represent your set of data as best as possible. So these would be examples of the lines that you could draw. So about like splitting right through the middle, and you can kind of so the next time, say you have a 21st chicken leg that was drawn randomly from the factory, it would be somewhere close to this line, and then it would just thin out. Two more questions. What is the maximum mass of the 20 chicken legs drawn from factory A? What is the minimum value? And what is the difference between them? And what about factory B? So now it's asking us, what is the largest quality out of the 20 chicken legs from factory A? So let's see here, and the highest one is 78. 78 grams is the highest. The minimum is 72. We subtract 72 from 78, and we get 6. So the difference between the max and minimum value quality of the 20 chicken legs is 6 grams. And we'll do the same for factory B. 80 subtract 71, and we have 9. So this differs by 6 grams, and this in factory B differs by 9 grams. And this differing is between the largest value and this least value. If only the specifications of chicken legs are considered, which manufacturers chicken legs do you think the foreign trade company should buy? Here's a solution. The average quality can only represent the central tendency and cannot represent the individual changes. From the data, Factory A is more consistent with the requirements. If we just look at the mean or the average, and we just sort of estimate that out of these two values, we know that the standard, the requirement, is 75 grams. Both of these factories have 75 grams as their average. But which factory can do a better job staying closer to that average? The average we want, remember, is 75 grams. So by first selecting a random set of data from a large pool of data, and we take the largest value and the smallest value and we find their difference, the one with the smallest differences means that they are closer to the requirement. Because here, Factory B has a larger chance of differing by, say, 9 grams. We want it to be as close to that requirement as possible, so we should choose 6 grams. Therefore, Factory A is more consistent with the requirements. So we already know that they are both about, their average is according to requirement, but which factory does a better job that's sticking and being more consistent with being to the requirement. In real life, in addition to looking at the average of a set of data, people also pay attention to the degree of dispersion of the data. That is, how far each of those sets of data ranges from that average. Range is a statistic that describes the degree of the dispersion of data. Range is the difference between the largest data in a data set and the least data in a data set. The greater the range, the greater the deviation from the average, and the more unstable. So this is another key word, unstable. Words such as stable, unstable, consistent, inconsistent are all important keywords. So the more unstable the quality of the product. Variance and standard deviation. Now we have a third factory, Factory C. So this new factory also participates in this sort of comparison, this competition between these three factories. 20 chicken legs are also randomly picked from this factory, and then we're looking at this graph that has Factory C's quality of chicken legs. So we know the average of the factory of C is about 75 grams as well. And this is the line we can draw to sort of show the average level of Factory C's chicken legs using a line. The range would be the highest, 79, minus the lowest, 72, which is 7 grams. What are the average and range of the quality of the 20 chicken legs in Factory C? The average is 75 grams and the range is 7 grams. How do you describe the difference between the quality of the 20 chicken legs in Factory C and the average number? Find the difference between the quality of 20 chicken legs in Factory A and Factory C and their average numbers respectively. So here, how could we describe the quality of 20 chicken legs and the average number? We first need to find the average of both Factory A and Factory C and then subtract. In Factory A and Factory C, which factory do you think has better quality chicken legs and why? Remember, Factory A and Factory C have the same average, but Factory A has a lower range than Factory C. Therefore, Factory A is more consistent with sticking to the requirements, and Factory A should still be chosen. Mathematically, the degree of dispersion of data can also be described by variance or standard deviation. So what is variance? The variance is the average of the squares of the differences between the individual data and the mean, which is this. So you would first find the mean of the set of data, and then subtract the mean from each data in that data set, and while squaring each of those differences and adding them up. Among them, so this x with the line over it is the mean of this data set, x1, x2, all the way to xn. S squared is the variance, and the standard deviation is the arithmetic square root of the variance. So the standard deviation would be S. Generally speaking, the smaller the range, variance, or standard deviation of a set of data, the more stable and consistent the set of data is. Let's do some problems. Calculate the variance of the mass of 20 chicken legs drawn from two factories, A and B respectively. According to the calculation results, which product do you think is more in line with the specification and requirements? Let's first calculate factory A. Again, you can always go back in the video and go to those graphs we looked at earlier, and this would be your equation for variance of factory A. You'll get 2.5. Factory C, you get 4.2. And the answer to question 2 is factory A is more in line with the specification because it has a smaller variance. Let's do another one. Kaylin Common participated in sports training, so just sports practice. The results of the 5 recent tests are shown in the table below. Whose results are more stable and why? This is the test number and these are their scores below right here. We're asked which results are more stable. And look at this graph. Okay. So here we have a table of calculating the standard deviation of the deviation of this data set. This is the formula we're going to use. So we get the standard deviation of Kaylee's 5 test scores is 1.84, and the standard deviation of Common's 5 test scores is 3.04. Therefore, Kaylee's test scores are more stable and more consistent. So let's look at method extension. First, we can take any benchmark number A. So we take A, a benchmark number, and then we subtract A from the original data to get a new set of data. And then we can find the variance of the new data set. So what it's saying is, we have something like 1, 2, 4, 6, 6, 8, 9. What is a benchmark number that we could use? We could probably use 6 as a benchmark number for this data set because it looks like it could be around the average. Okay, and then we subtract 6, which is the benchmark number A we chose, and then we subtract it from each of the pieces of data in the data set, which would be -5, -4, -2, 0, 0, 2, and 3. And then we find the variance of this set of data. This is another method that you guys can use in order to make your calculation easy. Class summary. Today we learned all about statistical dispersion, range, variance, and standard deviation. Here's what we learned. Understand the meaning of range and master the calculation method of the range. Understand the meaning of variance and standard deviation and is able to use sample variances and standard deviations to estimate population variance and standard deviation. So that wraps up the lesson for today, and it is also the last video on Unit 6 of this course. So again, if you like these videos, you can always subscribe so you'll be notified when we upload the next videos for Unit 7. So stay tuned, and remember, stay inquisitive.